right, let's go ahead and go over these. I've got simplify I to the 91st power. So what are we looking for? How do we break this down? Good. The highest power below 91 that's divisible by 4, which would be I to the 88th times I cubed. I to the 88th is just 1. I cubed is negative I. So 1 times negative I? Negative I. Questions on that one? Yep.
I thought it was I and 3. I.
Hmm?
When you did it before you added.
No, it's multiplied. This is I to the 88th times I cubed. Because that's why we can add those exponents to get 91.
Yeah.
Yes, ma'am.
Do we have to do all that, or can we just memorize the pattern?
You can do it here.
Okay.
Okay, B, you should have gotten negative 5 plus 12I. Any questions on that one? Yeah.
You have to put like that.
It's got to be in this order. It can't be 12 minus 5I. You've got to put it real part, then imaginary part. Okay, C is negative 10. Any questions on that one? You mean to work it?
Well, I wouldn't I squared.
Sure. We okay on C? Okay, D, you should have gotten negative 10 plus 6I. Questions on that one? Yep. This is a subtraction problem. We need to subtract this whole term here, this whole complex number. So I need to distribute that negative. So this is going to be negative 8 plus 4I minus 2 plus 4I. Or sorry, plus 2I. You're combining the real parts and the imaginary parts. So negative 8 plus negative 2 is negative 10. And 4I plus 2I is 6I.
So you don't distribute the negative and then like distribute it. You know, like do that and then.
No, because this is not a multiplication problem. This is a subtraction problem. Okay? All right, E, you should have gotten 6 plus 4I. Any questions on that one? Yeah.
Does it matter if you had 4I plus 6?
Yes. The most simplified form is 6 plus 4I. It's got to be the real part and then the imaginary part.
Why is that?
It's just kind of like how someone said standard form of a quadratic is ax squared plus bx plus c. Well, someone said that the standard form of a complex number is real part, then imaginary part. Just is. Just got to go with it. All right, on F, you may distribute the 5 first or keep it on the outside and distribute it at the end. What would you like to do? Distribute first? Okay, so this would be 15 plus 10I over 5 minus I. What do I have to do with the 5 minus I in the denominator? By the conjugate. What is the conjugate of 5 minus I? Good. Make sure you put parentheses around everything. And then let's go ahead and distribute. 15 times 5 is 75. Plus 15I plus 50I plus 10I squared over 25 plus 5I minus 5i minus I squared. Everyone okay with those two steps? Okay. So let's simplify. 15i and 50i is going to give me 65i. Plus 10i squared, what does that give me? Negative 10. 5i and negative 5i, those cancel. Negative I squared becomes plus 1. Because it's minus negative 1, which becomes plus 1. All right, so 75 minus 10. So this is 65 plus 65i over 26. Okay, then remember you got to split it. 65 over 26 plus 65 over 26i. And unfortunately, that does reduce. What goes in evenly into both of those? 13. 5 halves plus 5 halves I. Questions? Yes, ma'am.
So every time there's an I under the like in the denominator, then you always see the conjugate.
If there in the denominator there is an I being added or subtracted from something, you use the conjugate. If in the denominator was just 5i instead of 5 minus I, you could multiply the top and the bottom by I. Okay? All right. Let's continue on with our notes. First thing we're going to do is determine whether the complex number given is a solution to the quadratic. So if I gave you a line and I said, hey, is this point a solution? How could you check? Plug it in. Okay? Same idea. We're given an equation. We want to see if it's a solution, so we're going to check by plugging in. So where we see an x, we're going to plug in negative I. Okay, now it's a little tricky here. You've got to think of negative I squared as negative I times negative I. What is negative I times negative I? I squared. And what is I squared? Negative 1. So this is negative 1 plus 9. Does that equal 8? Yeah. So when it works, when you get a true statement, you know that the solution you tried works. Or the complex number you tried is a solution. So negative I is a solution. SOLN is in abbreviation for solution. Says determine this type. The way this question is worded, you need to say solution or not a solution, because it doesn't say yes or no. Is this a solution? Okay. 2, we're being asked to test if 3 plus I is a solution. So what are we going to do? Plug in 3 plus I for x. So this is 3 plus I squared minus 6 times 3 plus I plus 10 equals 0. So I'm going to go off to the side and square 3 plus I. Okay. Now remember, when you square a binomial, you can do the a squared plus 2ab plus b squared thing. Okay. So a squared would be 9, 2ab, good, plus 6i. Because think about it, you'd have 3i plus 3i. And then plus b squared, I squared. I squared, though, is the same as what? Negative 1. So how could I rewrite this? 8 plus 6i. And then what should we do with this negative 6? So minus, sorry, not 6, minus 18 minus 6i plus 10 equals 0. What happens with the 6 i's? 8 minus 18, negative 10 plus 10, 0. So what can I conclude? Questions? It's not a solution that can be seen on a graph because it's imaginary. We're going to talk about that more in just a second. Yeah. Oh, when we squared this binomial? Anytime you've got a plus b squared, it's a squared plus 2ab plus b squared. Any other questions? Okay. We've got x squared minus 36, or sorry, x squared equals negative 36, and we need to solve. All right, so what would we do to solve for x here? Square root both sides. So if I take the square root of x squared, I get the square root of negative 36. What has to go in front of my square root? Plus or minus. Do not forget this part. Okay? So the square root of x squared is just x. So x equals plus or minus. Let's think about the square root of negative 36. Remember that I can rewrite that as the square root of 36 times the square root of negative 1. Right? What's the square root of 36? What's the square root of negative 1? So you have x plus or minus 6i. Okay, so let's talk about this. This quadratic has two imaginary solutions. What are those two solutions? 6i and negative 6i. Okay? Those are those two imaginary solutions. Okay? A quadratic either has two real solutions, one real solution, or two imaginary solutions. Okay? Imaginary solutions always come in pairs. Okay? Imaginary solutions always come in pairs. And those pairs are always the complex conjugate. Would you agree that 6i and negative 6i are complex conjugates? Think of it as like 0 plus 6i. So the conjugate would be 0 minus 6i. Okay? All right, let's think about this. If this quadratic has two imaginary solutions, that means it has no real solutions. Correct? Yes? So if we have two imaginary, we can't have two real. Okay? A real solution, what does that look like on a graph? When y is 0, so when it does what? Crosses the x-axis. Okay, so that's what a real solution looks like. So if a graph, if a parabola has no real solutions, what can it never do? Touch the x-axis. Okay, this parabola never crosses the x-axis. Okay, you know how when we looked at graphs and we would be able to say this has one solution, this has two solutions, this has no solutions. Okay, that no solution graph did not cross the x-axis. Well, we're right in saying it doesn't have any real solutions. Instead, it just has these imaginary ones. Okay? So let's think about what this graph would look like. Which way, think about this equation, which way does this parabola open? What's our a value in front of x squared? It's positive, right? It would be positive 1. So it's got to open up. So where must the vertex be? Above the x-axis. Specifically, it will actually be at 36. And the parabola must open up. That's how we keep it from crossing the x-axis. Okay? Right now, yes, we're only talking about parabolas. Yes, Anna? Huh?
Like, what is 6i plus negative 6i according to the graph? Where would that point be?
6i and negative 6i are not points you can see on the graph. They are imaginary solutions. They cannot be graphed on an xy plane. They are the numbers that you can plug in to this equation to make it work. They're the only numbers you could plug in. It does work for if you allow imaginary numbers. No, there are no real solutions to this. There is no real point 6i and negative 6i. Yeah, that's the graph. This is still a real parabola with real graphs and real points. Okay? On your homework, there's a couple problems that say find the zeros and then sketch the graph. This is all I'm really looking for you to sketch the graph. Is the vertex above or below the x-axis, and which way does it open? For that part, I'm just making sure you understand when does it cross the x-axis, when does it not cross the x-axis. Well, I knew this parabola had to open up because my coefficient of x squared was positive. So I knew it had to open up, which tells me that the vertex must be above the x-axis because it could never cross the x-axis. How do I know that the vertex was actually at 0.36? If you rewrote this as y equals x squared plus 36, like moving this to the other side, then it's a transformation up 36. Okay? All right, look at 4. X squared plus 4 equals 0. What am I going to do first? Okay, I have no b values, so I'm just going to get my x squared by itself. So I have x squared equals negative 4. What am I going to do now? Square root. So I get x equals plus or minus the square root of negative 4. Let's think about what the square root of negative 4 is going to be. Yeah, 2i. Do y'all see why it's 2i? Okay. Let's look at 5. 6x squared plus 5 equals 2x squared plus x. Do I have any b values here? Like, do I have any single x terms? No. So this is one that I can solve just using square roots like we've been doing. So do I have to set it equal to 0, or could I just get the x squares on one side and the numbers on the other side? Yeah, I don't have to set it equal to 0. So let's get x squareds over here. So minus 2x squared minus 2x squared. So I get 4x squared, subtract the 5. 4x squared equals negative 4. You guys okay with that? All right, what do I do next? Divide by 4. So I get x squared equals negative 1. So x equals plus or minus the square root of negative 1, which is, so plus or minus I. So does this quadratic ever cross the x-axis? No. x-axis if the solutions when you solve are real numbers, not imaginary. Then it will cross the x-axis. If when you solve you get imaginary numbers, then it will not cross the x-axis. Okay? All right, I'm going to give you about 3 minutes with someone next to you. I want you to please work number 6 and 7. Okay, let's talk about these. If 3i is one solution to a quadratic function, what is the other? Negative 3i. Why? They come in pairs, and those pairs are complex conjugates. Do all roots come in pairs? Only imaginary roots come in pairs. Or complex roots. Okay? All right, so if I told you that 5 plus 2i was one root, what's the other root? Good. If I told you that 7i minus 3 is one root, okay, let's think about it. Okay, how could I rewrite this? Yeah, negative 3 plus 7i. Negative 3 minus 7i. Good. I don't think That could happen, but you never know on like a EOC or something if they might throw it at you in a different order. The correct order is to do A plus BI, and that's how we will always write it. Okay? Yes? Yeah, you change the sign of the imaginary part. Okay? All right, let's talk about 7. Which direction must this parabola open? Down. Let's talk about why. What does this 2 minus 7i as a root tell us? Why? How'd you know? Good. So that is an imaginary solution. Okay? And imaginary solutions tell us that the graph never crosses the x-axis. So it has to open which way? Down. Questions on that? What if I told you that it had one root that was 22? It would have to open up. Okay? Have to open up. All right. Please work 8 and 9 on your own, quickly. Yeah. Okay, let's look at 8. What would I do first? Subtract 4, so I get x squared equals 4. So x equals? Good. Because the plus or minus has nothing to do with real or imaginary. It's just whenever you write in the square root, you have to put a plus or minus. Because there are 2 numbers I could plug in here for x. 2 squared is 4 and negative 2 squared is 4. All right, look at 9. You got now x squared equals negative 4. What are our 2 solutions there? Plus or minus 2i. Everyone okay with that? Don't forget those plus or minuses. All right, look at 10. 1/2 x squared plus 9 equals 8. What should I do first? Subtract 9. So I'm going to get 1/2 x squared equals negative 1. Then what would I do? Okay, so x squared equals negative 2. Next up, square root. So x equals plus or minus the square root of negative 2. How do I simplify the square root of negative 2? Is it just 2i? Yeah, it'd be square root of 2 times I, or you can write it as I root 2. Do y'all see why it's not 2? Okay, because you can't, this turns into the square root of 2 times the square root of negative 1. The square root of 2 doesn't simplify. Andrew? Yeah, it's always on the outside of the radical. You can write it as behind the radical. You just have to make it really, really clear that it's not under the radical. Okay? All right, look at 11. 5x squared plus 9 equals 18 plus 8x squared. What should we do? Good. Let's get the x squareds on one side. and the real numbers on the other. So this is negative 9 equals negative 3, or sorry, positive 3, x squared. Then what? Divide by 3, so I get negative 3 equals x squared, which gives me what? Good, plus or minus I root 3. Okay? All right, let's talk about what's on your quiz tomorrow. Your quiz tomorrow covers 3.5 through 3.9. Okay? 3.5 through 3.9 starts with the quadratic parent function. Includes solving, includes graphing, includes complex numbers. So, first thing I want you to be sure and remember, all the different words for x-intercepts. What are they? Roots, zeros, solutions, okay? You're going to be asked to solve quadratics. There's multiple ways you can solve quadratics. What's one way? What's one method we've talked about? It's not solving. No? You can solve by factoring. Get them all factored out and set each factor what? Equal to 0. You can solve by graphing. How do you solve by graphing? Looks where the x-intercepts are, okay? And you can solve like we've been practicing today, just taking the square root of both sides, okay? If there's an x term, like a 7x term, are you going to be able to just take the square root? No, okay? You need to remember graphing. I could give you it in vertex form or standard form. You need to be able to graph your quadratic and tell me all the things about it. Concavity, axis of symmetry, vertex, y-intercept, x-intercepts, domain, range, all that good stuff. Okay? So don't forget about graphing. Don't forget about complex numbers like we're on our warm-up at the beginning. Okay? Yep, that's it. What else is due tomorrow? After party.